Hello, welcome to Mr. Franklin Explains Some Math. We're looking at how to solve one of these quadratic equations. This type of equation, I sometimes call it type 1 equation, or I might say that there is no bx term in it. You'll notice that there's an x squared term, a constant, and another constant, but no x term. So this is the method to solve one like this. If there's a bx term in it, but no constant, there's another method. And if there's all three terms, the x squared, the bx, and the constant, there's yet another method. Actually, there's several methods for that. But today we're focusing on just this type. And here's how it goes. The object of the game is to get x all by itself. And in order to do that, so what I want is x equals here. In order to do that, I've got to figure out what x squared equals. And then to figure out what x is, I will square root. Remember, there's always going to be two answers. So to solve this for x squared, I've got 5x squared plus 12 equals 57. You should notice that this isn't a zero. Duh, right? In the type of problem that we're looking at, we want to get the constant over to this side. In standard form, this equation would have a zero over here, but the steps would be pretty much the same. So in order to get the x squared by itself, first I have to get rid of this plus 12. I, of course, am going to do that by subtracting 12 from both sides, which is going to leave me with just the 5x squared on this side. So I'm going to have 5x squared equals, and let's see, what's 57 minus 12? I believe that is 45, right? So now I notice that I've got, is x squared by itself yet? Nope. So to get rid of this 5, since it's multiplied, what I need to do is divide both sides. Of course, by 5. So if I divide both sides by 5, what I'm left with is, oh wait, I've got what I want. So this x squared, when I take the 5 off of this by taking, this was 5 times x squared. When I divide that by 5, the 5's cancel, and I've just got x squared. That's what I wanted. And then I've got 45 divided by 5, that's 9. When I take the square root of both sides, so I'm going to square root x squared, and I'm going to square root 9. When I take the square root of both sides, the square root of x squared, of course, is x. And the square root of 9 is 3. But wait, there's more. Because remember, we're always looking for two answers when solving a quadratic. So when I take the square root of 9, I've got to keep in mind that 3 times 3 is 9, but also negative 3 times negative 3. A negative times a negative is a positive, so negative 3 times negative 3 is positive 9. Or rather, negative 3 squared is 9, so the square root of 9 is negative 3, or it can be positive 3. Usually we just talk about the positive, but here in quadratics, we've got to make sure that we're mentioning both of those. This way I know that the two x-intercepts of this parabola are 3 or negative 3. There's a slightly different way of looking at this one. This is the parabola, and we want to know where it equals 57, and that's at x equals 3 or negative 3. So that's the solution for 1A in solving the quadratics. There are a couple more examples to check out, but the method is going to be the same as long as there's no bx term in the equation. So stay safe, stay sane, and I will see you on the other side.